Hi, questions in thermodynamics in this textbook. Problem 3.9. 1 mole of an ideal gas with this capacity is heated A. At constant pressure and B. At constant volume from 298 K to 353 K. Calculate delta S for the system in each case. Solution. The entropy change is given by this one. Case A. Then the entropy change is given by this one. Then we get Cp. Then we have this result. Consider this case. Then we have this result. Problem 3.10. 1 mole each of nitrogen and oxygen and half mole of hydrogen at 25 degrees Celsius at 1 atmospheric pressure are mixed isothermally. The final total pressure is 1 atmospheric pressure. Calculate delta S on the assumption of ideal behavior. Solution. The number of moles is given by this value. Then we have this distribution. Then we have this result. Problem 3.11. Initially, 1 mole of oxygen is contained in a 1-liter vessel, and 5 mole of nitrogen are in a 2-liter vessel. The two vessels are connected by a tube with a stopcock. If the stopcock is opened and the gases mix, what is the entropy change? Solution. Suppose that all gases here are ideal. The entropy change for an ideal gas is given by this one. Then we find this result. Problem 3.12. Calculate the entropy of mixing per mole of air, taking the composition by volume to be 79% nitrogen, 20% oxygen, and 1% argon. Solution. Here is the result. Problem 3.14. A. 1 mole of an ideal gas at 25 degrees Celsius is allowed to expand reversibly and isothermally from 1 decimeter cube to 10 decimeter cube. What is the delta S for the gas? And what is the delta S for its surroundings? B. The same gas is expanded adiabatically and irreversibly from 1 decimeter cube to 10 decimeter cube with no work done. What is the final temperature of the gas? What is the delta for the gas? And what is the delta for the surroundings? What is the net delta S? Solution. Case A. For the gas, we have this result. For the surroundings, we have this result. Case B. We get the final temperature. For the gas, we have this result. For the surroundings, we have this result. Then we have this result. Thanks for watching. Bye.